As you know that there are few problems that in the IT department people observe that first thing that when the apps get developed, they needs to be provisioned for the external usage. Typically IT department or the production, they go to the sizing, and the sizing is based on what is going to be the average, what is going to be the peak. Now let's say that is an e-commerce site and it needs to be deployed. Throughout the year, most of the time, the load on the site would be somewhat lower side. But during the Christmas period or the shopping season, it goes up. In the earlier period, that when you do the capacity planning, you have to do is that do for the maximum one. So that was the one problem. Another thing is typically you need to buy all this hardware upfront and install and make it available. And the third thing that you need to have people to manage it. So these are the three main things. So upfront cost is a very high because you need to procure the hardware, etc. Then to procure the hardware, install, make it available, it takes a time. So the actual time to market or time to deploy is also another component. And third is to maintain that ongoing basis, you need people. So that's where the first value proposition from the cloud is the CapEx. CapEx, what we call as a capital expenditure versus the OpEx. OpEx is the regular, so this is GL head in the profit and loss, it makes a difference. So operational expenses. So upfront you don't have to pay a lot. You can get provisioned on the cloud. Second thing, the deployment would be a faster. Third thing is you can dynamically scale. You don't have to buy the maximum capacity or provision for that. So you start with whatever that the average load is. And then when the shopping season comes, at that point of time, you can increase the number of boxes. So this is a typical cloud value proposition at one side. And another side is that nowadays in the agile development mode, the people do iterative, very small releases, and also the flexibility for being innovative. Developers experiment, make it available to the production quickly. Third platonic shift is happening is on the app side. There are a lot of mobile apps are coming up, and the mobile apps are typically made by developers, individuals, and they do not have complete bandwidth to maintain the boxes or get the any kind of a data center, etc. And there are two reasons. One is that their financial capabilities as well as that the business proposition is not that high. So it is mainly could be experiment basis. So this is the third reason that we see a lot of consumption on the cloud side, that mobile developers can quickly come on the board, and if they need a backend, they can get the box provision on the cloud. So there is no upfront development cost is required, and ongoing whatever that they use, that's what they are going to pay for. So pay as you use. These are the like a cost, utility. It gives the flexibility. It has the agility. And so whatever that you get billed is the utility model is that you get billed for whatever that you use. Now next level, that what is the cloud stack? So if you look at the cloud stack, it's from the lowest level, it provides that abstraction at all the resources. It could be hardware, it could be storage. So there is the first level of the abstraction. So there are these hypervisors or the middle level that provides the abstraction. So VMware is one of the vendor who provides that VMs. And similarly, so up to this level is that once you do that virtualization and the upper layer consumer do not need to know that what is the underneath hardware. Hardware could be anything, but you can virtualize it and make it provisioned. And also you can provision in such a way on the same box there could be multiple tenants sitting over there. So that's the second value on the cloud side. So that way it separates out the responsibility. The cloud vendors manages the hardware, manages the whole virtualization, and the consumption side, the upper layer does not have to worry about that. So Then from the developer point of view, there are 3 layers that we deal with that. So whenever we are building application, there could be either we are using one of the 3 flavors of the cloud. The first flavor is that the very basic, the raw bare bone you can consider is that infrastructure as a service. So Amazon, Rackspace, so all these vendors, what they provide is that we can go over there, we can get node initiated or the instance of server initiated, and we can deploy our software on that. So it's a bare bone infrastructure available. So we don't have to maintain the life cycle of that. Instantaneously, we can create the instance. So that's the value proposition of this. So this is the infrastructure as a service. We can deploy any software that whatever you want. We can choose any type of OS we want. Like if you go to Amazon, right, when you are creating Amazon instance, you can select that which OS you want, like a Fedora you want, or and then you can get the version also. So, and there are a lot of Amazon images are there, AMIs are there, which you can use it to select. So that's the infrastructure as a service, and there are a lot of vendors are there, like Amazon. Then VMware Cloud is there, even Oracle also introduced, and CloudStack. There are a lot of infrastructure as a service. Now the next level is that I can still develop the software's application using the IaaS. So what is the PaaS then? The PaaS is a platform as a service. Now when I get to Amazon instance, as a developer, I end up doing everything. I need to select whatever the application server that I need to use. If there are, we are going to use the database, then you need to select the database. Then if there is a messaging server required, messaging server, there are any other services are required. So we end up doing all these component and assemble and make them work together. And so that is the responsibility of whosoever is actually provisioning on the cloud. So platform as a service abstracts this concern that as a developer, you don't have to worry about the life cycle of the components, even putting this component together. And then the next layer is the software as a service. Software as a service, most of us, we know the Salesforce, Workday. These are the examples, software as a service. So companies can just create account and then start their application instead of installing, say, CRM application within your in-house. You can create a company account over there, and all your sales representative can go to the Salesforce. So that way, you avoid all this IT infrastructure, etc. Of course, there could be some additional customization, but you don't end up developing the software. So this is the highest level, is that the software as a service. So today we are talking about the platform as a service, that is the middle stack. So, and why we are talking about platform as a service is that there are so many vendors there. It's always the question that how do we go about that, and what is the current status of these different platform as a service. At Google App Engine, almost 2007, 2008 started. Then Heroku got acquired by Salesforce. Then we have CloudFoundry. A couple of years back it came. Last year it really picked up. Now it is rebranded as a Pivotal. Then CloudBees is a pretty good platform as a service for the Java stack point of view. And there are many other, Jelastic and others I did not list. Even Microsoft Azure is also a platform as a service, and they also provide the Java. So theoretically, I can cover that also. So I selected few of them. And why I got into this process is there are a couple of things that when initially Google App Engine came into, of course, many developers who typically jump into the new technologies that time I got into that. Then couple of years back, while advising for a software for selecting a startup for selecting a PaaS, I went through a few of them. So that was the second time. And then third is that recently for a mobile startup, I was looking into another stack. The same question came up, and every time there were updates. So I thought that it is good to capture many of things. One disclaimer though, that it's difficult to cover all PaaS implementation with the same degree. So I didn't try each one of them, but most of them I tried. So I will be covering that. And so mainly at the end of the presentation, you should understand that what are the selection criteria, what are the main things, what are the main features are there, and then if you want to use any one of them, then which one would be the right one for you. So though the title of the presentation is that say how to select, etc., it is really going to be based on your own case. It is not like a one answer and then everyone will be happy that okay, only use this particular platform as a service and then it should be okay. So just for the comparison purposes, now if you go to Amazon EC2, how many of you actually have account on Amazon? Okay, 1, 2, 3, 4, quite a bit. So you go there and you can see that there are so many AMIs are there. And they are pretty much kind of say that, okay, we have this one with the complete stack, with Java, MongoDB, MySQL, these are all installed, right, pre-installed. And there are few from Amazon itself, and there are many other vendors, including the other software vendors, they put their own AMI over there. And pretty much you can get it, you can start it, many of them are the free and they are well tested. At least you can see that the rating point of view that how many are using it and what are the comments, and you can do the selection. So the question is that if it is available in such a way, then why should we be using any kind of a PaaS? So this is the main important thing. The one is that the pricing, of course, the PaaS pricing is at the done at a very different level, and the IaaS platform pricing at the basic, and then whatever the services that we use, that will be the additional one. The second one is that why one should be using IaaS also is a very important to understand. Using infrastructure as a service or EC2 directly gives a great flexibility. So you can choose your own OS, you can choose your own Java version. If you are using say MongoDB, which version to use it, MySQL, which version to use it, so that you can do. The configuration, of course, you can do it. The tuning of JVM, that is also, you will be able to do that. But all this flexibility also brings the responsibility, because it is, one is the flexibility, another thing that it's a headache for all of you, right? You will have to understand all these details. Typically, app developers should be focusing on developing the apps, not tuning and not monitoring or thinking about those aspects. So that way it's the flexibility and the responsibility. In case of, if you go with PaaS, then you cannot do that. There is a restriction. Your hands are tied. Most of the PaaS vendors don't even allow you to go into that on the box, on the say Google App Engine. You can't even get into that. So you don't know. You cannot monitor that that particular, whether it's a VM or box. You cannot monitor those resources. You cannot tune the JVM, and you have the very restricted versions of JVMs that you can try. And then that stack is actually made for a particular combination, that it will work with say MySQL particular version or MongoDB particular version. So those type of things. So there are a lot of restrictions, but one thing that surely it will work. But if the moment that you need to go beyond that, for whatever the reason you need some additional features which are not there in that particular release, you are tied up. So that's why a few of the issues, that advantages, so disadvantages over there. In case of infrastructure as a service, you end up building your own stack, which as against the PaaS, that stack is given to you. Then the next one is that the one of the greatest value proposition for any PaaS platform is that single click deploy, like a dev to production. That time is instantaneously is instantaneous. So you can just deploy it. Of course, if you are in a part of a larger organization, no one would allow you to just code something and deploy it. So that's a different thing. But at least you can theoretically, for whatever the purpose is, you can take it from the dev to deployment quickly. So you don't need any kind of scripts and processes. In case of IaaS, you will have to do yourself. Then the next level is the monitoring. So once you do the monitoring deployment, it is in production, you need to monitor it. In case of IaaS, you end up building those monitoring tools. Like for example, on Amazon Node, you will be putting Nagios or Monet or Java Melody. All these things will be putting for various purposes, and you will be using it for the monitoring purposes. So that's one side of the story. But at the other side, on the PaaS platform, one that you cannot do it because there are tools. But at the same time, the current state of affairs of all these PaaS platforms is that they are not good. They are fine. Means if you are developing some basic applications, it's good. But if you are really doing very large-scale application deployment, then those tools are not that much mature. So that's the current state of affairs. Of course, it is going to get changed over a period of time. Final just comment is that all the enterprises, all companies, they will typically prefer infrastructure as a service. They will prefer to go to Amazon, create the instances over there instead of create the PaaS. So that's a, but at the same time, I'm not saying that they will not do it at all. So there are experiments happening or the smaller projects which are customer facing. So these are the two things. The typically internal applications, they will be deployed most of the time on the infrastructure as a service. So they will be almost as the internal. They could be private cloud or even public cloud, but in that. And then any external facing, those are the only ones typically would be probably on the PaaS platforms. Okay, so now I'm going into one by one different PaaS platforms and just putting everything in the one slide. There are quite a bit vendors we are covering into that. And I'm starting from Amazon Beanstalk. If you really look at it, it is not as a PaaS. It doesn't qualify into that, but I will go into that. But it kind of blends from the infrastructure as a service to the PaaS. So what it is, it gives that one pre-built Java, then it has PHP, it has also .NET. Amazon also provides into allowing into multiple different OS selection, but essentially it gives a very basic flavor of PaaS. In case of Java, it is a Tomcat-based version. You can use RDS, or you can, RDS is like a MySQL or RDS database on the Amazon. Similarly, you can use from the NoSQL side Dynamo, and there is some basic monitoring is there and basic deployment. So that's all. It's a bare bone, but at the same time it's a free. So it is a very basic flavor of how IaaS blends into PaaS. Of course, since it is on the EC2, it opens everything which is on the EC2. That instance is available for you. So in that way, you can definitely get advantage of all these AWS services. S3 is the storage service, then the caching, the messaging, all these services are available for the consumption. Now coming to the security. So when you select the vendor, this is the one of the important aspect is going to be on the security side. And there are different flavors of the security. That's why there are all these standards, and Amazon does the maximum certification. So it is not just the information across the wire, but when you put that information inside that particular instance, who are the people monitoring it? How it is monitored? What are the processes? So even the processes are also involved. So those processes also needs to be audited. So there are different these standards and the different certifications these vendors go through that to assure that there is a secured practice and your data is not lost. So it covers procedural aspect, it covers the disaster, it covers the recovery aspect, that if something goes wrong, how does it go? Then it covers the even the denial of attacks, those type of things. So there are various standards over there. So that security is a big topic of the selection, but at the same time, from the vendor selection point of view, right, typically if you are going to go into the enterprise grade, then you will go through all these questions and look at the this security certification. But if you are going to be using for the smaller applications, so typically you use for the PCI certification, that what happens with the personally identified information. So those type of things, and then disaster and recovery. So there are very basic minimal last two standards. Typically people look at that SSAI 16 and then 3402. So these are typically, and the PCI one. So rest of the vendors I'm not covering that. Amazon has the maximum, the rest of them only has the last two. So on the security point of view. So what is my experience with the bin stack? So it is very easy to deploy. You can just get your WAR file and then you should be able to deploy it, and it get deployed on that Tomcat. Monitoring also is easy. As I said, that it's a very bare bone. It does not come up with anything, but at the same time, it does not restrict. It gives all the flexibility. So we have the, we can go to the JVM, you can and do whatever the changes we want to do. So that way it is, it's as good as whatever that you can get it at free of cost. Yeah, it is not that that good. Actually, out of all the Eclipse plugin, I liked CloudBees one. It is CloudBees is another vendor. It's pretty good. But otherwise, most of them, what they do is that Eclipse plugin is responsible only for the deployment, because the actual development you do with the whatever the Java project create and all that thing, that procedure is the same. So when these plugins are given by most of this vendor, what they do is that they handle between the your project to that whatever the instance and the security management, that if you are so that you can do the HCP in the secured way. So that part is handled. So that is what most of them do. What I would have liked is that all this Eclipse plugin, they should be able to do the, as a developer point of view, the remote debugging, right? So that's what is another thing, and it's some degree is fine. It's all vendor to vendor. It again is a very, so this why I'm giving this purpose, and I'm not giving the rest of the stack. That typically when we say that platform as a service, yeah, go ahead. Source control, it's not, they are not doing anything. So yeah, we have to be responsible for that. Yeah. We maintain our local, you can put that thing, you can get any Git, put it on some Git or say SVN repositories. And then typically for startup, right, when you don't want to own, because one thing that your actual instances are on the cloud. Second thing that most of the time, the actual development you will be doing on the cloud. Is typically most of the setup I involved into that, even the developers for development, they use the cloud instance, and the production also is a cloud instance. So you have your laptop and all that thing. So it is just like IT-less startups or IT-less software companies. So now, if you are in that environment, then where do you put the source code? Right, that also needs to be somewhere, because you cannot keep source code locally. So for that, there are a lot of services are there. Even just $8, $10 monthly, you can put all your source code for almost 100,000 lines of code of worth of that at a very cheap price. So there are all these services are there. But at the same time, some of the vendors do provide the SVN, that is the source code over there in the Google App Engine also, then in case of CloudBees, then OpenShift also. So there is a close integration with the Git, there is a close integration with Maven and Jenkins, with some of only with the CloudBees and OpenShift. So that way you can actually do the complete dev cycle very seamlessly. So they are developed, I call them as a development friendly PaaS. So okay, so So it is not just the stack. It is not when we are saying that it is not whatever the application server, etc. But it is including all the different services. So there could be all various services. In case of Google App Engine, Google has this URL fetcher, the mail, and then like a caching, queuing, scheduling. Those services are available. And then there are new services, like a last one is a text search, the textual search, because nowadays a lot of unstructured searches happen, so those also over there. So those, one aspect over this services, there is no standardization on the PaaS, absolutely no standardization. Each vendor can just create their own combination and this is their platform. So when you evaluate that, you cannot just say that based on the security, based on pricing, based on all other things. You also need to look into that what type of application that you are developing, and based on that you may need to choose a particular PaaS platform also. So that also plays a role. So Google App Engine came very early. It's very mature, and it started with this Python. Then they added Java, but when they added the Java, it is one of the most restricted platform that you will get. So once you get into that, the worst case in the PaaS selection, we consider as a lock-in. Are you going to be locked into the vendor? Because you moved everything to one particular cloud, and you did development for say a year or two, and then for whatever the reason you need to basically get out, either the support is not good, performance is not good, and whatever that, and then at that point of time how easily you can get it out. So that depends upon whether the platform is a standard based or whether the platform is actually a lot of proprietary stuff. So Google App Engine has the maximum proprietary stuff, and it also puts a lot of restrictions on the Java. So they maintain actually the whitelist of what you can use from the Java and what you cannot use it. So that's one thing. And almost for many other vendors is the similar thing. Like when you say that Google also has for RDBMS, for instead of MySQL, they have Google SQL, and that Google SQL is based on the MySQL 5.5. But then there are a lot of restrictions over there. Like for example, you cannot do certain say exports, the loading, downloading to the file. So there are certain commands are blocked over there. Then MySQL has that plugin, right? Install plugin, uninstall plugin. There is of course a reason, because if they are sharing this MySQL instance with multiple projects, and but MySQL itself is not actually developed as a multi-tenant, right? So unless MySQL is a multi-tenant, when you put that MySQL available and then it is a shared, it will be a problem. So that was some of the things that, of course, there are a lot of development in that area also. But in the Google case, Google has restricted on the MySQL also, and then you will be using lot of services in order to solve that problem. Those services, once you come out of Google, you will not be able to use it. Like for example, for NoSQL, you will be using Bigtable. Now Bigtable, you can use it only over there. Bigtable, if you go out, you will not get anywhere. So that is the another thing. That is what we call it as a vendor lock-in. So so these are the criteria. Typically in the Java stack, what are the things are provided, because the application we are thinking about the Java application, and what are the restrictions over there. Development is okay. Most of the PaaS vendors provide the Eclipse plugin. Some go beyond, and also many of them has command lines. You can develop in whatever that IntelliJ or something, and then you can deploy from the command lines. So that is also a possibility. Each vendor would have different special services. Like Amazon has fantastic services though. Means this mail services, messaging, Memcache, this image API that you can manipulate the images programmatically. So those are there. So those are the services. So if you are really developing some applications based on some of the cool services that Amazon has, then it's okay. You get locked into that and you developed on top of Google App Engine. The new of the services coming from the Google App Engines are enabling MapReduce, text search, and then they already deployed and made it available, but they call it as an experiment. So there are experimental services like OpenAuth protocol, OpenID, etc. I just listed few of them. There are pretty good installations are there. There is a long list of success stories that Google has put together. I also developed few small applications that is very quick. If your the resources consumption is low, it is almost free. So that is another advantage. Actually, on Amazon side also, micro instance is free for 1 year. So if you are in the startup, you are doing something, you can just create the micro instance. You just need separate credit cards, and you can create multiple instances and just multiple accounts, and you should be able to create the different instances if you want. So micro instance over there free. In case of Google App Engine, also the resource consumption, if it is low, the cost is also low. Later on, the cost is per consumption, and the resources consumption, the bandwidth, that's also. So the costing, right, when I said that it's cheaper, but the computing, the cost is very difficult. It is only thing that when you get that, remember that when you get that AT&T bill or some other bill, nowadays we get the flat price, that's a different thing. But you don't know what these charges, where are they coming from. So similarly, it's everything is like you breathe oxygen, that will be charged over there. So it's kind of up to that level. So, but some of them are the wall clock type. So it basically, it doesn't matter that the as long as it is in this limit, it doesn't matter how much you consume. It is just the calendar time or the hours that we compute. So there are different type of the pricing model. But in the considerations, please keep price at the little bit lower side. Having said that, recently I will give the example of what goes wrong. In one of the project I involved with, that after a month of deployment, this is a problem of the COO and CFO. They didn't look into the what's happening or the billing side of that. They got say bill whatever that we call as a bill shock, right? Almost $125,000. It is an ad network. It is basically because one of the biggest disadvantage of any of this cloud is that whatever is the easiest thing becomes the most problematic. Now we empower all the developers that you can create instantaneously. So in a way that instead of fixing performance problems, if it is slow, what would you do? In the old time when it was taking say 3 months to get hardware or 6 months to basically procure and all that thing, you will basically put all your energy to optimize it, solve all the bottlenecks and see how you can basically do that. But today when it is so quick to just add the boxes, oh, this is not the load, it's not standing the load has increased, all these requests are coming in a high volume. What to do? Add box. Again the load increase, add box. Because developers not, in this case, are spending time into optimizing. At the end of the time, it was very easy to go from 40 instances to almost 85 instances within a month, without even knowing that. Of course, then the whole bills went up. Another thing that happened is that this rack space, when you use external IP address, it basically charging is based on that. It's very weird pricings are there. So, and in case of Mongo, when you basically cluster, right, and we have the shards and we put the whole IP address, when internally they do the sync up, right, that internal IP address should be used. So instead of using the person who did the configuration, use the external one, and boom. Even for all this internal sync up, everything, the cost went up, and it is only when the bill came, because at that, in this particular case, there was no increase in the number of instances, but it just configuration difference. So long story short is that in case of all these clouds, it's very easy. It looks very simple. Is that just $0.12 per hour? It's not a big deal, right? It's what is it? Even the cheapest McDonald's also is more than $1. So you think that it's not that costly. And but if you start putting everything together, that cost really goes up, and we don't know what are the different things comes into picture. So that's one thing that how to monitor is also always the issue. So I covered the two things, and now I'm coming to the criteria, because I was just wanted you to get that what are the things are there. One is that we covered the Amazon Beanstalk, and then Google App Engine. And now let's look at it that what are the different considerations, and these are the first thing, and at the end of the presentation again I will go through that the current state and little bit on summaries side also. Now here one is the stack, the programming languages. If you are really dedicated to Java, it's a Java stack, but if you are in a hybrid environment, then other languages also being used. You don't want to use for one PaaS platform for one type of thing and another, because then that when the application need to work together, then that would be the whole cost is going to be high, because the different data centers would be involved in that type of activities. Of course, another thing when I'm talking about the data center, when really deployment happens and the volume is there, you need to see that where the data center is, because based on the location of the data center, the whole performance, if it is a very latency is very important, then it's going to get changed. Then the database, right? Database versions, type of database, if your application really is centric about on that. Vendor locking that we talked about, that whether you are comfortable to go with a vendor and you are confident that as long as your app is there, this vendor is going to be there and good enough. So that's another thing. Availability and maturity, that also is there. So there are a lot of questions, not just the, typically you can see that when the cloud was publicly available and what are the successful customers, what is the volume over there. Because for a small individuals or small shops, it will be difficult to get answers from all these providers. They can point you to a particular, say, processes and all that thing, but it will be difficult to understand that. So you can, but you can look at the SLA. Amazon has a fantastic, not Amazon, Google App Engine has a fantastic SLA though. So in a way that when the uptime is less than 95%, right, then there is a penalty, and then is a SLA is the uptime is less than that, say 80%, then even the half of your bill will be taken off. So that kind of SLA is also there. So punishment, of course, whatever the billing is not important. Most of the time, the loss of the business is very important. So look at the SLA, what is the uptime and all that thing. When doing any development in the cloud, we have to make sure that systems are going to get broken, or their instances are going to come down and crash and all that thing. Our application, whatever you develop, you need to think about that and has that provision. So it is, everything is going to fail. That has to be in the mind. So then additional services, what are the additional services that stack is providing, particularly monitoring, logging, debugging, security, these are the important messaging, because all these instances, right, they need to, in your system, if there are, they need to communicate with each other, you need messaging. Also another thing that it all depends upon, some of the vendors do not allow batch centric, cron job type or scheduler type activity. So you need to look at that part also, that whether it is in case of say Heroku, they have the two different type of actually dynos they call this. One is the web centric, another back centric. So they are providing that upfront. So you'll have to look at that who are not providing that. The security is also another aspect, that different security certification. The price, we talked about that, and then finally, if there is an issue that how are you going to get service. Now let's talk about the CloudFoundry. So CloudFoundry is pretty much decent in a way that it is an open source base. It is the one first open source PaaS platform. Even the platform itself is open source, and there are some companies like ActiveState. It has taken that and then made it as a private PaaS based on the CloudFoundry, and which is available. So coming to the CloudFoundry, you can get three flavors now. One is the public cloud, another is a private cloud. And one of the most important in case of the CloudFoundry is that you can create a micro cloud. It means that is on your local box itself, micro instance. So you can do the development locally. Why is it important? Right? It's a small thing, but why is it important? Yeah. It's a disconnected development, right? Most of the other things, right, you will have to connect. You cannot do offline. You are sitting in a conference, internet is not there, you can't do work. So that is the, some of the things are there. So offline debugging also important. You can better do debug. You have a lot of tools available for better debugging outside. So that is another thing. So on the CloudFoundry side, it's a basically JT based, just Spring source, and then now with this pivotal announcement and that project, there is a huge integration and enablement on the big data side. It is happening. They launched a new company called Pivotal, and that's it's part of the whole initiative. Under the hood, most of these PaaS platform, actually they are run on the Amazon. So they are on the EC2 itself. So that's, but we don't deal with the Amazon in that case. They may create separate instance, they may not create separate instance. In case of CloudBees, they create the separate instance and we get even the EC2 ID, etc. Database is also another thing, that MySQL, Postgres, MongoDB. And I have observed that this is a common trend. Most of the PaaS platform has the same thing. No wonder, because one is that they are all open sources, right? And the second thing that in the NoSQL side, like Cassandra can do, but Cassandra has a big administrative over it. In the contrast, Mongo is much more easier. It's a document centric, easier to develop, also easier to maintain in that way, or creating the instance and provisioning, isolating. So that way, the common trend I found that. But many other places I saw Redis and say CouchDB, that is also there. References in this case, Khan Academy, and then yeah.
The reference customers for this look like the same.
No, actually, it's my. That's what I realized when I was saying that it's a copy paste error. I think I used the same template. Then I realized when you were saying that, so it's a mistake. I need to correct this particular slide. Okay, so my experience wise, right, the CloudFoundry is pretty much, this last is also copied forward. It is the previous one had the issue. This one had the, this one. Yeah, Spring thing, right? It is a Google App Engine. It's basically anything which is beyond that, it is given. But the CloudFoundry is a Spring based, so it does not have any issues on the Spring side. Okay, so next, this is one of the very good platform from the developer point of view, CloudBees. Very easy, it gives the complete cycle from the integration point of view. Under the hood, again, it is on the EC2. Many other platforms are supporting PHP, Ruby on Ruby, or Python, Scala, Clojure, all these different programming languages they support. But CloudBees exclusively supports the Java. CloudBees founder came from this JBoss. They sold it to Red Hat and then started this one. So that is the very pure Java play. Another thing that is very unique, they have the two kind of a separate clouds. One is the dev at cloud and run at cloud. And you look at the dev at cloud, it's pretty much full cycle of the development it covers. It has source code control like a JIT. It has a build, that is the Maven. It has continuous integration with Jenkins. It has a Sonar for test coverage. It has Selenium for the testing purposes. So if you think that the Java testing and Java development, all the major tools that we use, all of them are there. And in addition to that, they have additional, like for example, this new Relic integration is there, means their partnership is there, means of course we'll have to pay a little bit more, but then Papertail is there for the logging, the whole distributed logging and the detection, etc. So those type of tools are there, so they made efforts towards that. So one is the dev cloud and another is the run cloud. So the run cloud is of course this Tomcat J2E in EC2, very easy to deploy, easy to monitor. The tuning is one thing that issue I felt. So we don't have much more ability to influence any kind of a tuning. So it is good for typical standard web apps, particularly on the lower end of it, but very impressive end-to-end integration, at least the usage side. And they have impressive list of successful customers also. Yeah, it is pretty much because this is a bare bone. It is using the standard open sources. So it is as long as the key is that as long as we don't use the native services and we use the standard based services, then good. Like for example, if you are using say any kind of a queuing, then if you use with JMS, then at least your code will be portable. So that type of things that you can look into that. Then Heroku is another impressive one. It started very early. It is backed by Salesforce, so that way it is a very stable. It supports long list of these languages. For us, Java is important, so it is based on the Jetty server, and monitoring purposes they use the New Relic. Development here also you can do the download the toolkit, that tool belt, and then there is a Git and Maven. So this is the typically in this case what we do is that we are actually, you ask the question what happens to the source. So just like CloudBees actually is hosting the source in the dev ad. Heroku also you do the Git push, and then the whole your code will get pushed over there. So that way it is actually Git based, and then it is actually we are pushing the code over there. Databases, Postgres, MongoDB. One important aspect of the Heroku is that it has a marketplace of add-ons. You can create ad, and there are a lot of apps are over there, and they will almost they claim that thousands of those kind of plugins are available. And if you look at that, then with those plugins putting it together, anything which probably you need for development, Neo4j or any other databases, any other monitoring, any other tools, you will find it over there. So that is one advantage. Of course, then the moment you start using into that, you are tightly coupled. So that is also another thing. So, but at the same time, it has a lot of these plugins available. One impressive thing that I felt is that it has this auto backup for any data. Every 60 seconds, it keeps on backing up. Any data, customer data goes beyond 16 MB, it again backing up. So that's pretty much good. Differentiator I talked about, reference customers are pretty good. They listed lot of different type of this one customers. So for me, it was fine the experience in getting into the Maven Guild, pushing into that. I started initially with the ambitious application, little bit big size application, but most of the time I could not deploy on most of the this one way or another. So what I had to do is that limit and then just come up with the simpler one. But I wanted to test is that the basic application and then some database interaction. So typical observation is that you still need to do some config changes upfront for the way the database URL, the database connectivity is there. And otherwise, the programming wise didn't need to do anything much more different point of view for the basic applications. So OpenShift is also another completely open source PaaS, and now they announce enterprise also. So they have different flavors. They have free shift they call, mega shift another one, and then another is the enterprise one. So it is open source and it is coming from Red Hat. So this is the only one you can see that with a full J2E. So most of the other things that you observed so far, I did not explicitly say, but they do not cover the J2E. They are mostly Tomcat servlet based deployments. In this case, and they are giving that JBoss Enterprise edition, which is a commercial edition, which is pretty good. If you are really in the JBoss world, there are a lot of these rules and messaging and all other services are part of it, which we could be able to use it. Of course, then you get locked into the JBoss, but JBoss is also open source. So look at that point of view. Under the hood, again, EC2, most of the databases are same. Just like Heroku, you got the application gallery, but it is very young. OpenShift itself is a very young initiative. And I don't see that much more stable, referenceable customers as of now over there. It is good to experiment there. The whole development, means the design itself is a development centric. So these people have interesting concept is a cartridge. Even you can change the app server. So that's also very interesting thing. I didn't try, of course, but they claim it. So there is a concept called cartridge over there. So you can plug everything or change everything. So that is the thing. So it is a very good vision. Hopefully it will strive, and then if we can get some kind of a open source commitment, then this is a one good. CloudFoundry is another open source. CloudFoundry coming from the Spring source, so it will always be, it will never go to J2E, it will be always on this track. Oracle Cloud is the new one, which Oracle is a big mighty force, but at the same time, it's not catered toward the most of, or rather it is catered towards the Oracle stack. Oracle has this ADF framework, then Oracle has this various services, so it is also catered towards much more enterprise class. So enterprise services, identity management services, those type of services, they are also integrated and available over there. If you are working, say, Oracle's Fusion's hosted deployment or the cloud, and then you need to add some apps on top of that, then this cloud would be good. But otherwise, it is recently launched, so that the whole stability and all that concerns that you will have to see. Of course, Oracle has been in that hosting business for a long time, from the Siebel as well as the Oracle hosted, so that way it has a background. Now, finally, from the best cases, right, these are my summary. This is the important slide. So Google App Engine, good SLA, good price, stability is also good, but you get locked into that. So it is your call. So if you are okay with locking into using the services and build wonderful application using the Google services, it's a good thing. Lot of services there. Microsoft, of course, is a .NET. You go, otherwise Java, don't even consider. If you are .NET house with some Java thing, you go with that. Amazon Beanstalk is that if you need a lot of flexibility and some standardization, then you can use it. CloudFoundry is a good, because it's open source, and so that is good. It gives the flexibility. CloudBees also is good from the dev side point of view. OpenShift is a good vision, and if you are really developing J2E and JBoss type application, and you had been in the JBoss environment, you can go with that. And Oracle, of course, if you are using with the Oracle ADF framework for your internal application, then you do that thing. So summary is that all these things are evolving. They are not mature enough. The flexibility is very less. There is no standardization. There is a danger of locking is there. So I will be sharing these slides anyway, and gives very less control. Only last two things are important. Then if I'm giving all these negative things, then why should I be using it? So one is that for startups and mobile apps or some experimental enterprise apps, you can consider and get to adopt that. And once they get mature, then you can go to that. But if you are considering for your enterprise, if you are part of a big company, then it is a different decision. You need to consider and of course, then different people would be engaged into that. So that's all. I think only few people asked the question and we don't have much time left, but if there are one or two questions I can ask so that others can disperse, and then we can still answer the questions. Yeah. So as far as the session is concerned, we end, but now you can ask the question. Yeah, Jelastic is a good one. It's similar to this one, CloudBees. Jelastic is coming from the Rackspace. It has the similar basic stack is there. Usability is good. no vendor locking that way. So it is pretty good. Yeah. But it is still one of the, I consider it like one is the very stable, mature players. Jelastic has one advantage is that it is coming from Rackspace. So Rackspace is also as mature as Amazon. So that way it has the infrastructural maturity is there. Yeah.